Let us learn another problem from electrostatics. Welcome to my channel, children. Here you have a capacitor P and you have another capacitor Q. These two capacitors are having same area. The plates are separated by same distance. Let us read the question now. Capacitors P and Q have the identical cross-sectional area A and separation D. The space between the capacitors is filled with a dielectrics of dielectric constant epsilon r, as shown in the figure. Calculate the capacitance of the capacitors P and Q. So let us learn the formula for it. The capacitance of the parallel plate capacitor is given by a formula C equal to epsilon A by D. Here, one capacitor is filled with air. Its dielectric constant is 1. Another capacitor, another part of the capacitor is filled with dielectric medium. Its dielectric constant is epsilon r. Let us now go with the equivalent capacitance of capacitor P. Right, this capacitor P is divided into two capacitors. One is completely filled with air, the other one is completely filled with dielectric. This is completely filled with air, whereas this is completely filled with dielectric. And both the capacitors are separated by the same distance D. Right, okay, this is also separated by D, this is also separated by D. Whereas their area, here the area of the air-filled capacitor is A by 2, whereas here the dielectric filled capacitor has the area of A by 2. This is the little change that we have to use it in the general formula to get our answer. So these two capacitors in turn get connected parallel. So we'll be using Cp value. Cp is the sum of the Ca and Cd. Ca plus Cd. This is a simple way of understanding the problem. So let us go by step to get the right answer. For capacitor P, the capacitance of air-filled capacitor is given by Ca equal to epsilon naught epsilon r. The area is now A by 2 divided by D. The epsilon r here is 1. The epsilon r here is 1. So we substitute epsilon r equal to 1 and we simplify this formula Ca equal to epsilon naught A by 2D. Right? Let us keep this near the capacitor. Ca equal to epsilon naught A by 2D. Let us go for the second capacitor filled with dielectric medium. So its value is Cd, that is given by epsilon naught epsilon r into A by 2 by D. Here the value of epsilon r is as it is. There is no change. The 2 will be coming to the denominator. The final value is Cd equal to epsilon naught epsilon r A by 2D. Let us write this value near the dielectric filled capacitor. Cd equals epsilon naught epsilon r A by 2D. So let us find the effective capacitance of this parallel combination, and we have a formula for it. The formula is Cp equals Ca plus Cd. So let us substitute the value of Ca and the value of Cd. So in these two value, we have epsilon naught A by 2D is common. We'll take this term outside the brackets, epsilon naught A by 2D. Then we have within bracket 1 by epsilon r. So we got the effective capacitance for the first capacitor P here. Let us now work on for the second one, the Q. So here in the capacitor Q, right, the area for two capacitors are same, whereas the gap between the two capacitors are different. The air-filled capacitor has a gap of D by 2 and dielectric filled capacitor has a gap of D by 2, whereas both the capacitors are having same area, capital A, whereas here A and here also the area of the second capacitor is A. These two capacitors are in series combination, one after another. So the effective capacitance will be Cs, right? 1 by Cs will be equal to 1 by Ca plus 1 by Cd. This is what we use to find the final value. Right? Okay, good. So let us go step by step to get the answer. Capacitance of air-filled capacitor is Ca epsilon naught epsilon r A, but the gap is decreased d by 2. So the 2 will be going to the numerator and writing epsilon r as 1. So you will be getting final answer Ca equal to 2 times epsilon naught A by d. Let us go for the second capacitor filled with dielectric medium. So this is given by CD equal to epsilon naught epsilon r A, and divided by the gap is reduced d by 2. The 2 will be going to the numerator and epsilon r no change. So CD equal to 2 times epsilon naught epsilon r A by d. Let us write this, okay, near the dielectric filled capacitor. These two capacitors are connected in series. So the effective value of these two capacitors are given by a formula 1 by Cs is equal to 1 by Ca plus 1 by Cd. When two capacitors are connected in series, let us better use this formula. Cs is equal to Ca Cd by Ca plus Cd. So substituting the value of Ca and Cd here. So I'm not telling each term here. Look at the screen. And in the denominator, you have a term 2 epsilon naught A by d as common, taking out of the bracket. And within the bracket, you have 1 plus epsilon r. So in the numerator, you have 2 epsilon naught A by d and 2 epsilon naught A by d getting cancelled. So in the epsilon, this epsilon r, you leave it as it is. Okay, remove all the term from here. So we get Cs is equal to 2 epsilon naught A by d multiplies epsilon r by 1 plus epsilon r is the final answer of this problem. Follow my channel, children. Thank you.